Hello everyone, in this tutorial I want to show you how to design a parametric bench like this you can see in these pictures. So first of all, I go to the grasshopper and double click on canvas and use by arc. The first component I want to use today is by arc. It is you can see this the bifocal, this stagular component can show us the name of the component. So go to the by arc. You can see we have 5 inputs for the by arc. The start point, as you can see, it is so clear that we need a point here for the start point of the curve. I mean our curves will start from this point. For the start tangent, we need a vector that is tangent at the start point to the curve. So we need a component that create a vector for us for this component, for these inputs. So I type xyz xyz vector xyz. You can see here. We can see it has a x component, y component, and z component. It means that we should import numbers as a x coordinate, y coordinate, and z coordinate. And you can understand it is so familiar and it is so close to the construct point. If I type a construct point, I had a error in dictation. So construct point, you can see the construct point has 3 inputs: x coordinate, y coordinate, and z coordinate. So instead of vectors in all the components, you can see you can use the points instead of vectors, because vectors and points, vectors, both of them needs a coordinate of x, y, and z. So a very useful component that create a vector for us is MD slider. You can see the MD sliders has a output of the x and y coordinate. So instead of vector x, y, z, you can use MD slider at 2D points, because it has a 2D x and y. For the z is 0. So here, instead of now xyz component, we use MD slider as a start point. If you want to see the result of the point and MD slider, I mean the vectors that we have created, you can use vector display. Vector display, we need a point and vector. This is our vectors, but it's better to multiply by 10 to see better, magnify this one. So we can see the result here now. This is a vector that we have created, and these vectors will be tangent at our curves. So we don't need it now. So very important thing is that in all other components that you want to use in Grasshopper, you can use point and MD slider instead of vectors. So for the endpoint, it is clear that we want a point for the end of our curves. So I type, for example, 50, 0, and 0. This is the end of our endpoint. And again, we need another MD slider for the end tangents, and we put it here. So you can see the result of our components. You can see the curve, the by arc, and we have a ratio. Is better to talk about this. The ratio is here, for example, 0.3. If you put it in 0.3, and you can see the result. You can see this something like a point here, that you can change it to have a different shape of the curves, but it is as a default is 0.5, and we will put it in a 0.5. So the first step finished. Now we want to divide these curves. We don't need the by arc itself, we need the division of the curve. So I use the divide curves, and make a establish connection between by arc and curves. And it's better to talk about the output of the by arc. It consists of 3 parts. The first arc is here from the first point to the middle. Second arc is the middle from to the end, and by arc means both of the parts, both parts of the curve. So I connect the by arc to the curve, and you can see we have some points on it, and we can increase it, the count, to the 15. We have 15 points. Now we don't need the by arc anymore, so I disable the preview. So we have some points. We have 16 point here and 16 point here. So we want to continue with these points. So The next part that we want to do, we want to move these two parts. I mean, it's better to say we want to copy this points in these directions. I mean, in a y direction and in minus y direction. So I use the move component. You know, the move component in Grasshopper works as a copy. So I connect the point to the move here, but as a default it goes up, I mean in the z direction, so I would change it to y directions, and increase the amount of y direction by, for example, 10.36. Now we can see the result here, and again I want to move it here with this y directions, but I right click on it, and in expression I type minus x to a negative direction. So if we want to change it, you can use you can see the result here. It works together. So we need this part, so I mark it because I want to use it later, so to find it easier. Here we need this part. Okay, this is the first sets of point, second and third of point. We don't need it here, but we need these two parts at the end of the process. So the next part, I want to move it in a z directions. So again, I use the move component for these three sets of points. So the first one is here, the motion is z, but I don't want to use just one number to the z directions. I want to use a component called graph mapper. So it is better to talk about the graph mapper a little more. I type the graph mappers and right click on it, and a graph type I use, for example, linears. I think it is so familiar for you with linear equations in mathematics, and the equations of this line, it is y equals to x, and you have read it and you have studied this in high school or university. It means that we have inputs and outputs. If you input, for example, 1 for x, the output is 1 for y. If it is 2, for example, it is 2. If it is 10, it is 10 for y. And these are equals. So this graph mapper here, you can see this is the x-axis and this is the y-axis. This is the x-axis and this is a y-axis. So here we should import the numbers as an x. For example, if you put 1 for the inputs, the result you can see in a panel, it is 1, because the inputs and outputs are equal, as I told you. For example, if you put 2 for this one, and you can see the result is 2. If it is, for example, 4 or 5 or all other numbers, the output is y. So this is just for one number. If you want a bountiful of numbers, you can use, for example, a control panel. For example, 1, 2, 5, 6 together, and multi-line data. And you can see the control panel, the outputs. Okay, for the 1, the output is 1, for 2 is 2, and for 6 is 6. So you can use panel, but it is not very user friendly. It is better to use range to make some numbers. Be careful if you want to connect the range to the graph mappers. The domain of the range should be equal to the domain of the graph mapper. So our domain here is between 0 and 1. So the domain of here should be between 0 and 1. If you change it, for example, you can double click on it and you can change it x0 and x1, for example, between 0 and 10. If you change it between 0 and 10, you come here and set domain between 0 and 10. So the domain here should be equal to the domain of the graph mappers. And another thing for range is that the output of the range is one numbers more than the steps. For example, if you input 10 for the steps, the output is the 11. Because the steps, it means that we want to divide this one. For example, as we're to talk about more, for example, if we have one line here, it is one division of the line. It is consist of two parts, two numbers, the first one and the second one. If you have, for example, this part, for example, we have two parts. I mean, our step is 2, but the output of this one is 3 because it consists of 3 points. So the output of the range is one more numbers, and the steps is the number of divisions here. So if you connect this one to the graph mapper, you can see the outputs. The results are the same. For example, you can see the inputs here. You can see the inputs here, but I changed this one. This is the input, this is the output, input, the output. But as I told you, the equation y equals to x, it means that every number on x is equal to y. But I change it here, the numbers, and you can change it, the output of the y here. You can double click to the y and, for example, say that the output should be, for example, between 5 and 15. I mean that I want to reparameterize the numbers. Now you can see the inputs between 0 and 10, and the output is between 5 and 15. It means that the minimum number of the list equals to 5, and the maximum of the list 10 equals to 15, and all other numbers are between these them in proportion of these two numbers. So the graph mapper, it creates some numbers for us, and the second result is that it can reparameterize our numbers. It can put our numbers between a range that we want. So we can change it, for example, graph type to sign. You can see the result is different, but the numbers are between 5 and 15. You can change and move the grips and see the different numbers here. So we'll work on it in our project, and we will learn more about it. So here I want to put a graph mapper for the factors. So I type the graph type, the graph mapper, and I right click on graph type. As for example, I use the sign here, this sign here. For the inputs, we should use range. Okay. And the domain of the range is between 0 and 1. The domain of the graph mapper is between 0 and 1. It is true, it's correct. And for the steps, we need 16 numbers because we have 16 points. So here we should type 15, as I told you, 15. And the next part is that our result is between 0 and 1, but we should change it, for example, to 4 here, 4 and 12, for example. 4 and 12 here, and we should connect it to the factors. As you can see, the result of the outputs, the numbers is started from 4 and increase like the pattern of this one, and you can change it to see the result of this one. So the numbers increase and then decrease again. You can see the increase and decrease in the panel. So this is the first part that I move the point upward. So go to the next part here for this point. Again, I use move and connect this to move. And for motion, we want to use Z directions. And for the factor, we use graph mapper. And here we use graph type, for example, to Bezier. We connect it to this one. Again, we use range. The domain is here is between 0 and 1. We can change it, for example, 0 to 5. And again, here I change it to 0 and 5. And for this step, we should type 15, or it is better to use this one because the numbers of the point are the same. And here, for the result is between 0 and 1. You can see the result here before changing this one. The result is between 0. This is not, it's not moved upward, but you can change, you can see the change here. This is the 1, just 1. But you can change it, for example, to 5 and 12 or 10. Now you can see the result here between 5 and 8, and you can change it now to say this one. And again, I want to change it to, for example, 2 to this part. Okay, this is good. Or you can change it a little more. Not bad. Okay, this is enough. And for the next part, for these points, I want to move it again. Connect this geometry to this one in a Z directions. And again, I type graph mapper. And, sorry. And put the graph type into, for example, this part. Okay, again I connect to the Z and type range. The input is between 0 and 0. The step is 15. Where is 15? It's better to type it again. Step is 15. And the output is between, for example, 4 and 8. Now we can see the result of this one. So it's a little untidy, and it's better to mark them. Mark this word, and this set of points. And then it is better to disable the preview to see the no, we need this one and we need this one. Okay, now the next part I want to do that is used to make curve, I mean interpolate curves between some points. So I type the interpolate, you can see the interpolate here. We need 5 interpolates. The first one is here, connected to this one. For the second one, interpolate, we use this interpolation. The next part is, where is the next part? Here is the next part. For the next part is here, and the last part, you can see the last part here. So now we don't need the points anymore, so I disable the preview now. So disable the preview. Okay, so we have some interpolate curves, and it is better to merge them together. So I use merge. So I connect this one, second one, third one, fourth, and the last one. The next component I want to use is a loft. So as you know, the loft can loft some curves, some profile curves, and you can see the result of our bench, but we can change, manipulate it a little more. For example, we can make it closer, maybe. No, sorry. Where's the Y here? Okay, we can change it a little more. Okay, this is good. And the next part I want to do, I want to close this one. So I find the first and the last curves. I use loft again, the loft component between this curve and this curve, and you can see the result here. And it's better to join, Europe join, Europe join, Europe, and we have just one Europe now, and we can disable the preview of this one. So the initial shape of our bench is completed, but we want to use contour. As you can see, if you can see our previous film and video and tutorial, you have seen the contour component, but I'll tell you about more. The contour component. The contour component has 4 inputs. The first one is the shape that we want to contour. We want to contour this one. The second one is a point that we want to start the contour from it. As a default is an origin, but you can, for example, use this point to start from this point, but it's better to use the origin here now. And the directions is a X directions. Of course, this is the X directions, but not all the time it's not the X directions. Here our bench is in X direction, so I use the X direction. And for the distance, I think 0.5 is not bad. We can change it if necessary. Now we can see the consequence of our contour. We have some curves, and the next part that I want to do is to use boundary surface. You know, the boundary surface can create surface from a planar and closed curve. So our curves are the result of our contours are planar and are closed, so we can connect the contour to the boundary surface. So we can see here. And the last part I want to use is to make thickness here. So I use extrude. I want to extrude the boundary surface, and in a X directions with a 0.3, I think it's not bad, and connect this to the directions. And you can see the result now. So it is better to bake it. Sorry, it's better to make it. So you can see here, I want this one. So we can see here the result in the render viewport, and this is our render viewport about this bench. So in a future video I will tell you how to prepare this one for fabrications. Okay, if you have any question about this tutorial, you can drop a line behind this video. Have a nice time. Goodbye now.